Differentiating is easy. It is just GCSE maths. So there's two things you need to know. Firstly, we are going to be using our gradient formula from GCSE, which is y2 minus y1 over x2 minus x1. And the second thing that I like to make all my students aware of is, well, what is dy over dx and why do we use it? So first notice it's a lowercase d. D in the Greek alphabet is delta, and you've most likely seen it as a triangle, probably in physics. So you should know triangle means a change in. This is a big change in, and lowercase is a small change in. Therefore, if we're using a lowercase d, this is just a small change in y over a small change in x. y2 minus y1 over x2 minus x1. So how do we specify a small change? Well, if we think about differentiation, and I will draw a graph here, and if we have our graph here, and we want to find the tangent, sorry, the gradient at this point, we used to draw a tangent, so that would just be like that. But what we're doing is we're saying that we want to find this line here, but we want to make this line infinitely small, because the closer it is to the red dot, so I will just draw one more line. So for example, if we compare the green one to the blue one, the blue line will give us a more accurate gradient function. Therefore, we want the gap between the red dot and the blue dot to be basically 0. And we'd say that mathematically by writing the limit of the change tends towards 0. So where does the h come from? Well, we can label this graph as y equals f of x. And if this is the point x, this gives us f of x. And our second point, which is up here, is just going to be x plus something, because it's x moved by a certain amount. And this is where we use h. Therefore, if you substitute that into here, you get f of x plus h. So we have all the knowledge now. We know to calculate gradient, it is just y2 minus y1 over x2 minus x1. We know we want to minimize the gaps between both of these, so we have a limit in place. And we understand what the dy over dx actually means. So if we put it all together now, so if y is equal to f of x, then the differential of x is equal to y2. I will just write the coordinates here. So our first set of coordinates is x and f of x, which we will call x1 and y1, and then our second set of coordinates is x plus h and f of x plus h. So this is x1, y1, this is x2, y2. So let's plug in the formula. So we get y2 minus y1 over x2 minus x1. And we can simplify that to give us this. And remember, we need our limits to ensure that we're mathematically saying that the difference between these two is as close to 0 as potentially can be. So we tend towards 0, which gives us the final thing that you find in your formula book, or the thing that your teachers have maybe poorly explained to you, for the proof of differentiating from first principles. We will go through an example question in our next video, so drop us a follow and follow along.